Okay, so we get to talk about solving percent problems today. How does that sound? It is super fun. Okay, we're solving percent problems, and we're here for a couple of days, actually. Percent problems often give even adults lots of problems. So you guys showed yourself to be pretty strong last year with this, and the goal is that we're even stronger after this time that we spend, right? Percent. Actually, right in the word percent, we have what it means. What's the operation that we have in percents?
Division.
Per means division, right? We're dividing by cent, and cent is Latin for 100. That's it. So a century has 100 years, right? And there are how many cents in a dollar? 100. So there you go. So percent, when we use this little symbol, do you see the 100 there? 1 with 2 zeros, right? And then we could write it in words, percent, 100. Also, we could take any percent and put it over the number 100 and change a percent to a fraction, just like that. Okay? Good. So, give me some common percent. Lauren. It says 80%. 80%. So, if I have 80%, how can we write that now? Everybody try writing that as a fraction. We just said how, right? So, as a fraction, what's the first thing that you're looking at here, Jonathan?
Well, it's between two decimals.
But I'm asking for a fraction.
It could be 80 over 100 or 8 over 10.
Good. He says 80 over 100. Then we can start reducing that. It could be 8 over 10. It could even be smaller. We could reduce that too. So when we have 80% of something, do we have the whole thing? If I have 80% of the class, do I have the whole class?
No.
I have some part of the whole. And so you often hear me say that percents are parts of whole, right? What is the part over the whole? Is it possible for us to have more than 100%? Yes. So sometimes the part could be greater than the whole. If the part is the same as the whole, if I have 100 over 100, I just have everything. I have the whole, 100%. Okay? So part over whole equals, do you remember what we said last year? We can set up every percent problem in the form of a proportion. So that's why we were talking about proportions yesterday, is today we're going to use it with percent problems. So part over whole equals, Emily? Percent over 100. Good. If you can remember that in life, that can be really helpful. All right. You can see this is a proportion, right? Part over whole equals a percent over 100. When we write the percent, the actual number like 80% in Jonathan's example here, do you see that we drop the percent sign? We don't usually use the percent sign in our problems with operations. We change it to a fraction or a decimal equivalent like you were going to do, okay? We could also say that A over B equals the percent over 100. Notice that these are just variables that represent the part of the whole, right? Part or the whole. Often the words is over of are used, right? Like 80 is what percent of 100 or something? Is over of are common in percent problems. So we look for these key words in our real world problems. I've had students who set their percent problems up as proportions with everything that they do, and they have such a high degree of success, it's wonderful. There are other ways you can find percents and you can do things, and we'll talk about another way today. But if you love the proportion style of setting things up like this, it will be giving you success in most every case, okay? So if you like it and you know it, use it. What percent of 60 is 9? So we need to change that to, let's change that to a proportion. What percent of 60 is 9? So when we start, if you remember last year, we always begin with, there's our little proportion, and we always are going to have 100 down here. So that's easy. We just have to figure out where is the unknown thing here. So it says what percent. So where does the percent show up in our proportion?
P.
And so where is it? Is it in the numerator, denominator, or the numerator on the right? Where is that? Good, on the right. And we often see the letter N used to represent unknown percents, so I'll use that. You could use a different variable if you wanted. So now we need to figure out which is the whole and which is the part. So which one here is the whole? It's the 60. And so 9 is some percent of 60. What percent of 60 is 9? And now we're back to yesterday. Just solve your proportion.
Oh, yeah.
And what could a person do right now before they even cross product or... Nick? You could simplify 9 over 60. What is that?
That's 3 over.
So he's dividing out the 3. Did everyone hear that? So we could rewrite this as 3 over 20 equals n over 100. And that's really nice because 20 times what is 100? 20 times 5. So 3 times 5 is 15. And we can now say we have 15 over 100 and convert that back to a percent, 15%. 15 over 100 can now be written as 15%. Very good. Okay, let's try it again. Let's have a volunteer. Who would like to, on the board? Okay, so set up your proportion. Okay, we'll just Control C. Go ahead. Can you just set up the proportion first, like put the fraction marks? Fraction equals fraction. So she's already showing us that what we're missing is the percent. So she has that variable as a P in this one, okay? And there you go. And she sees that we can just blow up this fraction with a factor of 5. $75 over 100 is 75%. Good job. Okay, who would like to do the next one? Okay, Jimmy. This is a little different, isn't it? It says, what number is 30% of 90? So let's see how he sets this up. Okay. What do we know, Jimmy?
90 is 12.
Okay, so what do you have in the denominator over there?
Well, you're going to change 30% into the decimals, 0.3.
Wait a minute, 30%, what are you saying when you say 30%? Are you giving me a percent? Do we know the percent in this problem?
Oh,
Do we know the percent in this problem? We do. So we're going to back up. You can actually fill in your known percent, right? Where does it go? Yeah, 30, right there. No decimal. No, oh. That's just a 30. 30 over 100 is 30%. There it is. And now, what do you know? The part or the whole? It says, what number is 30% of 90? The whole. So where does that go? Good job. And what number? We don't know the number, so he's using n. Okay, good. Now you can solve it. Is there any way to reduce this? This fraction that you know here? What can you do? You could divide it by something bigger. Look at that giant 0 at the end of those numbers, right? What can you divide by?
5.
Something even bigger. Look at those giant zeros at the end of those numbers.
Or 10.
By 10. Okay.
Yes.
Which is really nice, isn't it?
Yes.
Do you see what happens here? When we start to put equal signs, I don't know where the beginning and end of this is now. Do you see? So I would prefer that you take this information that you're coming up with and put it, whoops, sorry, didn't mean to do that. Take this new fraction that you have found. I only want the 3/10. It's not going to let me just take the 3/10. So I'd prefer you write the 3/10 right underneath here where you're simplifying, okay? start again, go ahead. 3/10 equals, bring down the other side, to the left, underneath it. There you go, n over 90. Now, do you see the quick step you can take to find n?
Yes,
So, sorry, we're running out of room. Let me raise this up a little bit. Isn't that blue box interesting here? Anyway, what do you have, Jimmy? Say it again. What divided by 9 equals 3?
27.
Good. N equals,
27.
you want to jot that down? N equals 27. Thumbs up if you got 27. Very good. Okay, did anybody look at this differently? Who here look at this as 10 times 9 equals
Yes.
90? So 3 times 9 equals 27. That works too. It might be an easier way to look at it. Okay? The percent equation is another way to look at the proportion that we're used to. Sarah, up here. So this is just another way to look at the proportion. I already told you you could just use all the time, okay? The percent equation says A is P% of B, which is saying you can actually multiply your percent by the base to find a particular percentage, okay? These words are what really give us some difficulty. A is the part. A is some part, percentage. Percentage is the part. P is a percent. Do you see how we have that little word percent in both of those pieces? Which is why it gets really confusing. Of base, which is the whole. Okay? So, in our previous example, we said part over whole equals percent over 100, right? The part is the percentage of the whole. Equals a percent over 100. I'm going to back up and look at one we've done here. In this example here, down where 9 is what percent of 60? Do you see 9 is a percentage of 60?
Yes.
9 is 15% actually of 60. We found this out. 9 is a percentage. 60 is the base, the whole. So these are just some words that we use when talking about percents. Right? So how does one use this? Now, this question here, what number is 12% of 85? Could we answer this using our proportion we've already used? Yes. So as I said, if you love that, use it. But there is a really fast way to do it using this percent equation. What number is 12% of 85? All we have to do is take and multiply the whole, as you see up here. Percent times the base, right? A equals PB. So all we have to do is take that percent, 12%, and multiply it to the whole, 85. But we never write a percent with a percent sign. So how do we write 12% as a decimal? Let's say it together. 3, 2, 1.
0.12.
0.12. There it is. Okay? So if you want to know the percentage of something, you can multiply the whole by the percent. 0.12 times 85. And then we go do it. And who's doing it? Who are my star people who are doing it on paper? Everyone is my star people, right?
Yeah.
You're all doing it. 0.12 times 85. And what do you have? Who has it? Star student? Michaela. Who has that? Anyone else? 10. Oh, good. We've got 5 people. 10.2. Now, does this seem reasonable? Would 10.2 sound like it's about 12% of 85?
Yeah.
Does that sound about right? What is 10% of 85? 10% is 8.5. Just move that decimal once over, right? 8.5. So 12% would be a little bigger than 10%, right? 8.5, 10.2, it sounds reasonable. Do check your answers for reasonability. Can you say that? Reasonability. It's a fun word, reasonability. Almost as good as multiplicative inverse. Okay, let's try it again. Who can set this up? Well, actually, how do you want to set this up? There are multiple ways. Juliana?
I did A equals 56.
The problem is, look at here, we're finding a percent. And so I don't really think that you're finding a percent if you're saying A equals.
56 equals.
Actually, that's a whole, that's your base. Go back to your proportion and tell me, what do we know? Or what do we need to know? Either one. What part of this proportion are we looking for? And where does that go? Over 100. So we're looking for this, okay? Now tell me, where does 56 and 49 go? Which one is the base, the whole? It's actually 56. So the whole, the base goes here, and your percentage goes here, okay? Do you see a reducibility here, Mark?
You can also do addition brackets of 56.
And that's usually what we find, is the base or the whole is next to the word of this whole 56. What percent is 49 of this whole 56, okay? And so we could reduce this, right? 49 over 56 is actually what? What can we divide by, Alana?
You could divide by 7.
And you would get what?
You would get 7 over 8.
Over 8 equals n over 100. Does 8 go easily into 100?
No.
No, so we might use our cross products now, right? And we end up with, or does anybody notice a faster way than using cross products? I mean, what is happening to n here?
It's being
It's simply being divided by 100, right? So what's the inverse of that?
multiplication.
We can simply multiply both sides by 100. And now, do we have n isolated?
Yeah.
Yes.
So has anybody found that shortcut already? When you were solving proportions? Anyway, we have 700 over 8. And what is 700 over 8? Anderson?
87.5.
Got it? Who agrees? 87.5? Sounds good. 87.5%. Does that seem reasonable? Does 49 seem like it is getting close to 90% of a number? Of the number 56?
Yep.
It is. It's reasonable. Okay, so do check for reasonability.
215